Let's see how test of hypothesis can be done about a population mean when we have a large sample. To do that, we need to estimate the so-called test statistic, and for the case of population mean large sample, it is estimated in the following way. So z-score is equal to sample mean x with a bar minus mu0, which is the value of mu, so the population mean specified in the null hypothesis, divided by sigma, which is population standard deviation, divided by the square root out of n, the sample size, which we know can be approximated in the following way. So the sample mean minus the value of the population mean from the null hypothesis, divided by s, sample standard deviation, and divided by the square root out of n, which is the sample size. As for the test statistic, this is a so-called sample statistic computed from information provided in the sample that the researcher uses to decide between the null and alternative hypothesis. So therefore it's a very useful tool. We will need it in order to say whether the null hypothesis is true or the alternative hypothesis is true. And for example, if we go back to the first example, to calculate the z-score for that example, we will need to know the population mean, the sample mean. To 2400, this is the value of the mean from the null hypothesis, and we will also need to know sigma and the square root out of n. So when it comes to the rejection or non-rejection, so acceptance of the null hypothesis, there are two techniques that can be used. So first technique is based on computing the p-value for the computed sample statistics. So for example, for z-score, or comparison of the computed sample statistic, for example, z-score, this z-score, with the critical one that we can get from the table. So let's have a look at how the p-value for test of hypothesis can be obtained. It involves, as you can see, a number of steps. So first, we need to determine the value of the test statistic. So we need to calculate the z-score using the information about the sample mean, about the population mean, the hypothetical population mean, standard deviation, and the sample size. After we get the z-score, we can get the p-value. And the p-value, in case of the one-tail test, will be equal to the tail area beyond z-score in the same direction as the alternative hypothesis. So for example, in case of the negative one-tail test, the p-value will be the area underneath this distribution curve to the left of the z-score. So we would need to take 1 and subtract this area, which will be equal to the area between 0 and z-score, and 0.5, so the right side of the distribution. In case we have positive one-tail test, the p-value will be equal to the area to the right of the estimated z-score. So to get this p-value, we would need to take 1 and subtract two values, so 0.5 for the left side of the distribution, and the value of the distribution between 0 and z-score, which we can easily get from the table with critical values. When it comes to two-tail test, it's called two-tail for a reason, because we are on the both sides of the distribution, so we can be either to the left or to the right of the distribution. And this area, to the right or to the left of the distribution, they are the same, and they're equal to the half of the probability. So after we've got the p-value, we can, in the next step, would be to compare it with the significance level. We've already discussed them. There are three most common significance levels: 1%, 5%, and 10%. And here is the decision rule. So if the estimated p-value, so the one that we get from using the table, using the test statistic, is higher than the critical value, so it's higher than 1 or 5 or 10%, we do not reject the null hypothesis. So we say that the null hypothesis is probably true, And the second option, the second possibility is when the critical value alpha is higher than the estimated p-value. In this case, we reject the null hypothesis. So we say that the null hypothesis is probably not true. And we say that there is enough evidence to accept the alternative hypothesis. So we will say that with the evidence provided, the alternative hypothesis could be true.